Hi, I am Irshad Kareem. Let's see one of our patented work on regenerative braking in battery electric vehicle. Regenerative braking is a widely accepted and employed concept. In this technique, an energy is being recovered the source while the vehicle is decelerating. While this concept is a very old and is being employed widely, in our technique we have proposed a strategy where the energy recovery can be maximized irrespective of driving speed. And in this technique, we have also addressed the limitations of the previous art where energy recovery during low speed is limited and basically it is not possible. So through our proposed technique, the rate of deceleration can also be varied, like slow and fast deceleration can be achieved. This figure shows interaction of various forces when a three-wheeler EV is driving on a varying road slope. The interaction of various forces has been considered in a mathematical modeling so that the limitations of traction and braking can be included on an experimental setup by considering the vehicle dynamics. This figure shows the block diagram of regenerative braking which has been proposed in these works and the load emulation which has been considered on an experimental setup where the driving profile includes the varying road slopes. So this is the two-level voltage source inverter with high current capability. This is the traction motor, which is the IPMSM motor being powered with the help of a lithium ion battery. This traction motor is mechanically coupled to an induction motor which is emulating an EV load through its slip speed control. It is being powered through the three-phase grid and controlled by IGBT based two-level voltage source inverter. In our proposed technique, during deceleration, only the three lower switches are being used to maximize the energy recovery in this lithium ion battery. And the duty ratio of these three switches are calculated as per the estimated back EMF of this IPMSM motor. So this is the final switching selection block which selects the PWM pulses for all the 6 switches as per the driving conditions. So during the deceleration or during the electrical braking requirement, the proposed technique is being executed and the switching selection blocks selects the PWM pulses and the corresponding for the corresponding switches, that is the S2, S4 and S6. So this is the experimental setup where the connection of each equipment has been done as per the schematic diagram which has been shown in the previous slide. So let's see the execution on an experimental setup. So this is the traction motor, this is the IPMSM motor, it is of 48 volt 48 ampere. So this one is the digital signal processor which is F28335 and it is being integrated with other signal conditioning circuitries. So this one is the low voltage high current voltage source inverter powering the traction motor which is IPMSM motor here in this case. These are the sensors. So if we see the results on DSO, the yellow color shows the battery current, sorry, that is the stator R phase IPMSM current, and blue color shows the DC link voltage, red color shows the line to line voltage of the IPMSM motor. So here the blue color shows the battery voltage, battery terminal voltage, and yellow color waveform shows the current being drawn from the battery. So here if we see the current reversal, that is the energy is being recovered in the battery for a very long period of time, which was not possible through the conventional control, that is the field oriented control. Additionally, the energy recovery is also higher as compared to the conventional method. So this DSO shows the reference speed and the point at which the electric braking or the vehicle deceleration started. So this is the lithium ion battery, which is of 51.2 volt, 86 ampere hour. Thank you for your attention.